So in this video, we're going to take a look at some past exam style questions on the current laws and investigate how it's affected by potential difference and by resistance too. Okay, so let's look at the first circuit. We want to work out the current through each of the lamps X, Y, and Z in each question. So circuit A, X is in series with the ammeter, so X is going to have a current of 1.2, as there are no splits or junctions between X and the ammeter. Y is going to be, well, we know it's 3 going into the junction, 1.2 goes one way, so 1.8 must go the other way, and Z, those two currents are joined back together, so it's going to go back to 3 amps. Circuit B, the first one I'm going to start off with is Z, which is in the series of the ammeter, so its current must be 2.5 amps, and then through X, we are going to do 4.5 minus 2.5 gives us 2, and then Y is in series with X, so they must have the same current. Okay, circuit C, again, I'm going to start off with Y. Y is in series with the ammeter 1, so it's going to be 1.5. Z is in series with ammeter 2, so it's going to be 2.0, and X divides into X and Y, so it's got to be 3.5. Okay, so which current, P, Q, or R, is the smallest? The correct answer here is going to be Q. So P is going to be the biggest because that's coming straight out of the battery before it even splits. If you go through branch R, that's only got 1 resistor in it, whereas branch Q has 2 resistors, so it's got double the resistance, so Q is going to have half the current R is, and then Q plus R is going to equal P. So which lamp is controlled by each of the switches? Okay, so X is coming straight out of the power source, so that's going to control all of the lamps. If you open X, no current flows out the battery, so none of them can be switched on. Y is only in the branch with B in it, so that one controls B only. Z, you can see, is in the branches D and E. If Z is open, current essentially has to stop at C, it can't go beyond, so it's going to control D and E. Okay, so a battery, an ammeter, a switch and a lamp and a resistor are connected together in a circuit like we can see. With the switch open, the ammeter reads 2.4 amps. When the switch is closed, the reading increases to 4.0 amps. What is the current through the resistor when the switch is closed? Okay, so the thing to realize here is the resistor and the lamp are in parallel. So adding components in parallel has no effect on the other components. So the current going through the lamp is still going to be 2.4. So we're going to do 4 minus 2.4 gives us 1.6. Write down the ammeter readings A1 to A3 in this circuit. Okay, so A1 is just going to be 2.1 because we can see that's just in series with the 2.1 amp reading, and it's the same with A3 actually. A2 is going to be 2.1 minus 1.3, and then A3, they're going to join back together, so they're going to go back to 2.1. Bulbs X and Y are identical. A3 reads 0.3 amps. What do ammeters A1 and A2 read? Well, if the resistances are identical, A2 is going to be the same as A3, so that's going to be 0.3, and A1 is going to be the sum of those two, so it's going to be 0.6. Okay, choose the best 2 answers. Do not choose more than 2. The circuit has 3 identical ammeters A1, A2, and A3. Which statements J, K, L, M, and N are correct? So since we're looking at current, we're going to look at the Kirchhoff's current law. So A1 is going to split up into A2 and A3, essentially. So we need to make sure our answers agree with that. All ammeters have the same reading? Nope, not possible. Unless they were all 0, I guess. The reading on ammeter A3 is greater than that in A2. Well, A3 is going through the smaller resistor, so yes, I would agree with that statement. A2 is greater than A3. No, the resistance for A2 is much bigger, so the current is going to be lower, so that doesn't make sense. The reading on ammeter A2 is identical to that of A3. Well, they've got different resistances, so why would they be? And the reading on A1 is the sum of A2 and A3. Yes, that's exactly right. What is the current shown on ammeters A to D in each of the circuits below? All the values are in A, or amps. So A is just going to be 1. It's in series with the original ammeter, so that's fine. Okay, this one we're just going to do 0.3 minus 0.1, gives us 0.2. Getting a little bit more complicated now. This one is going to be the sum of the two currents, because those two currents join together to give us this one. Okay, so this one, first thing I'm going to do is work out what the total current is. It's 0.7 plus 0.8. That gives us the total current 1.5. 1.5 minus 1 gives us 0.5 amps there. The ammeter below reads 1 amp. All the resistors have the same value. What is the current through the black resistor? So if these resistors are all the same, the other branch parallel to the 1 amp has 1/3 the resistance. Therefore, it would have 3 times the current. So we're going to have 3 amps going through this one. So our total current is 4 amps coming out of the battery. If these two resistors on the right are identical, the current is going to split equally between them. So the current through the black resistor is 2 amps. Look at the circuit below and answer the questions that follow. Ammeter A5, which is down at the bottom, it's a little bit blurry. A5 is the one at the bottom, reads 3 amps. All the resistors have the same value of 10 ohms. Not that it actually matters for this question when we're dealing with currents. What are the readings on ammeters A1 to A8? So let's put in that one. So we know the current going through ammeter 5 is 3 amps. Now I'm going to look at A2 next. So A2 has half the resistance, therefore it's going to have double the current because they've all got the same potential difference. That one's easy. A3 and 4 now. So this one has 3 times the resistance as I2, so the current is going to be 1/3 of that, so it's going to be 2 amps. And we can also check that it's actually 2/3 of I5 as well, so that works too. And then A6 is going to be adding the 2 at the bottom together. A7 is going to be adding all the currents together, and then 8 and 1 are going to all be the same because they're all in series with A7, and 3 and 4 are both 2 amps. Okay, so that completes this video looking at past exam questions on current.